I'm ready.
Okay. Are you typing? Yeah. Okay. Just
Go.
Hello, we are Group 1. My name is Harry.
My name's Holly.
My name's Tristan.
I'm Myra.
And I'm Chris.
And we're here to present our findings for the A-Call Frog product. First, we'd like to thank you for hiring our group to find better ways to improve your product and to improve the quality. Unfortunately, we can't be there in person right now because of certain circumstances, but we'd like to thank you for giving us this opportunity to present via over the internet and video. And first up, Tristan is going to talk about what we did and what our findings were for the original frogs.
So, starting on our project, we're going to talk about our very first frogs. So, as you can see, this is a picture of our frogs. And starting at the top, minimum of 4 base frogs were created using 1 sheet of plain printing paper. So this is just the kind of paper that you get straight from the computer, nothing special. Each of us made our own frogs. Chris made his, Holly made hers, Myra made hers. And this is just regular 20-pound, 8.5 by 11, but we did, it's important to note, cut it down to 7 by 7 inches, just because it was easier to work with the square with the original directions. Also, eyes and numbers, as you can see, were all drawn using a black Sharpie marker. And each frogs were numbered and initial for traceability. So this is really important to note for the project. So as you can see, the number and the initials for each frog. So that way, when we're going back and putting in all the data, we can see, you know, if one landed outside the specifications, it was this person and this number of frogs. So maybe there's one with an obvious defect. Finally, or almost finally, we have no additional items such as paper clips, tape, or googly eyes were added to our frogs. Once again, just normal black Sharpie and paper. And each frog took about 3 to 4 minutes to take with the original instructions. So, to make, which is pretty long. Chris will get into the improved frogs later, but 3 to 4 minutes per frog is pretty sizable amount of time. So we were definitely trying to cut that down later on. And moving on to the next slide, we have our chart where we measure our jumps, color-coded to make it even easier for the people measuring. So as you can see right here, our starting position right on the bottom at the light blue paper where it says start. And then after that, we have the measurement that we created on the side here. Instead of using a ruler every time to measure it, it made it a little bit easier to just have it connected directly to our measurement chart. So it's going in standard inches. And after that, you can see our green zone, which is our ideal landing spot for the frog, inside our specification limits of 2 to 6 inches. Anything outside is not ideal for our customer. Moving on after that, the red section that we just talked about, with the X's, is outside the specifications. And besides our chart, we're going to talk about specifically how we measured the jumps. So, to start, if you remember that blue box here a second ago, the tip of each frog's nose would be right at the bottom. And, next bullet. And it's important to note our nulls because not every company does this the same way as we do. So what we consider a null is if the frog was to land outside of the chart. So if someone put their finger on it, it was to jump to the right, left, over, that would be null. And additionally, if the frog was to jump backwards behind this blue start box, that would also be null. So it wouldn't be considered a 0 or even a negative. It would just be completely null and it would get a new jump. And here's the video for our initial frogs by Chris.
Alright, so this is group 1, and Chris will start testing his frog. Okay, let's give it a couple tries. There we go. Okay, so this one didn't land in the specification, but we are recording it through where the frog's tip of the nose is, and it has to land upright on its legs. And so as you can see, this one is right here at the 7-inch line where his nose is, and that's where we'll be recording it.
Okay. And then as you can see our data right here, 4 frogs per person, and then all 5 people are listed up there. Green boxes are every frog that landed inside of our specification limits, and they have our calculations that we're going to talk a little bit more about in the next slide. Okay, so before I pass it on to Myra, we're going to talk a little bit about the statistics that we got from our initial frogs. And just to start, our X double bar, which is basically an average of the averages for each person and their frogs, came out to 3.8, which is our yellow, orangish line right in the middle. Our sigma hat came out to 2.0. Then we have our ZU and also our ZL, 1.1 and 1.1 and 0.9 respectively. And then finally, the most important number, our CPK, which came out to be 0.3. So the CPK is very important in this kind of manufacturing process and measuring for like accuracy and making sure that the frogs go as centered as possible. So 0.3 is not exactly ideal. Yes, these are our initial frogs. We're hoping this number would be a little bit higher, but something in the 0.75 to 1.5 range would be better. And Chris will talk about that later with our improved frogs. But for now, I'm just going to pass it on to Myra. Who's going to talk about the fishbone.
Okay, so for our root cause analysis, we created a fishbone analysis. So it helped us figure out what was wrong with the frogs we were creating. So we're going to go over the 6 M's in the fishbone analysis, which is material, measure, mother nature, machine, method, and manpower. Okay, so on to the fish's head, or in this case, the frog's head. Our frogs aren't landing within the specification requirements, which is like the green part. Okay, so for the first stem, which is material, for material, we think that our paper could be either too big or too small, and it's not the correct size when we're creating our frogs. Also, our paper is too thick or thin, and it's causing a variance of results when we're testing our frogs out. Okay, so now on to measure. For measure, we believe that our frogs could have been tested more, so we could have obtained a more comprehensive result. So instead of just doing 10 test sample jumps for each of our frogs, we could have done a little bit more to get a more comprehensive result. Okay, so on to Mother Nature. For Mother Nature, we believe that gravity could have caused our frogs to not land correctly. Also, the wind may have affected the way the frogs were landing, which they weren't landing within the specification requirements. Okay, so now we have manpower. For manpower, we think that the operator-to-operator variability of how the frogs were made and tested. Also, we think that the instructions were not interpreted correctly by the employees. Okay, so now we have method. For method, we think that our instructions were not clear enough and they did not have enough information, and it caused confusion amongst the employees. Okay. Also, we believe that the operator's technique of jumping the frogs were different. For example, I used my fingernails because they're long, and then my teammates used either a pencil or their fingers to jump the frogs. Okay, so now we have machine. Unfortunately, we didn't use any machines because we didn't want to cause any harm or injuries to our frogs. Now we have Holly.
Alright, so I'm going to be talking about the project charter first. Project charter is a great step to take at the beginning stages of any project because it develops the organization and really establishes the purpose. So listed at the top, you can see the roles that each of our team members took within this project, and then right below there you can see the problem statement. Now, our problem statement reads, the major problem we face in producing our frogs is that they weren't landing within the specifications of 2 to 6 inches in distance, and therefore we had an unacceptable CPK of 0.3 and an unacceptable yield of usable frogs of 47%. So we aim to improve our frogs in order to meet specifications and give us a minimum yield of 95% and double our CPK with a 0.6. So below that, you can see the factors and our goals set out just in little boxes. Even though they're stated in our problem statement, we really want to show what we're trying to achieve. So our goal is for CPK is at 0.6, and our goal of usable frogs is at 95%, which means 950,000 usable frogs per million. Now you can see our payoff matrix. It's set up just as a Punnett square is, and on the y-axis you can see the payoff level. So it's either a small payoff or a big payoff, and then On the x-axis, you can see the implementation. Is it easy to implement or is it tough to implement? We wanted to have an easy implementation by changing the method. We were able to improve our usable frogs, and how we did change our method was by looking up YouTube tutorials and determining which one we could understand best as a team, and then everyone as a team uses that specific video, maybe referring back to the instruction sheet just for reference. Then below that you can see our business opportunity. We found that even though we changed our method, our material was still influencing our CPK level. So we decided that to use a heavier material so it would jump better. The quick win really established the yield rate to improve, and business opportunity established the CPK to improve. On the right, the tough to implement process we felt was unnecessary because it is a 6-week process, and creating new machinery or using new machinery would take longer than that, as well as setting up an entire assembly process. So we did use action planning along the way. As you can see, we have our what, who, and when chart. The what establishes the scope, the action, and commitment that the project required, and the who established the person who would be in charge and overseeing each action item, and the when represented the deadline when it was due. So as you can see, we did meet all of our requirements, and we are performing based on deadline. So up there you can see the control chart. The control chart is used in order for the workers to reference and to understand the factors and the specifications that we are requiring of each part in each process. So you can also see the method where we chose a sample size and we chose the frequency of using that sample size. So for example, since it's an extensive list, I'll talk about process number 10, and that was the launching the frog. So we launched 20 frogs 10 times, and the only way to establish if they met the specifications was by direct supervision and then reporting that and seeing the data. So we said that maybe we need instructions for the people who are launching the frogs, and once implemented, if they didn't allow for a better, smaller variance, that we would have to change those instructions until we reduced the variability. All right, and I'm gonna pass it off to Chris, who will talk to you further.
All right, so these are our new and improved frogs. As you can see, they're green now, and that's because we changed the material and the method, as mentioned before. So we're gonna go over the method in a little bit, but real quick, talking about the material, instead of using white construction paper, we used instead of using white computer paper, we used green construction paper. Now what that did is the construction paper is a little bit thicker, so it gave our frogs a little bit more spring. And then we also took that construction paper and cut it down from 8 by 11 down to 3 by 6. Now, what that did is it decreased our assembly time down from, I think, 4 minutes to 2.5 minutes. So huge improvement right there. Everything else was kept the same, so we used Sharpie to decorate the frogs. We didn't add anything to them like googly eyes or paper clips. And as we'll go over right now, they heavily improved in staying within the specifications. So these are our results. Like I said, each frog took almost a minute to a minute and a half less to make. So huge improvement right there. And then they all stayed within the specification limits better than before. And one thing to note is because of the thickness of the paper, they were a little bit harder to, I guess, fold. You needed a little more finesse when making them, but it all worked out in the end since our assembly time was decreased by a lot. So huge payoff right there. And this is our video of our new frogs.
Okay, this is group 1 doing the A quality frogs, and these are our improved frogs, which we made out of green construction paper and heavier paper than the first frogs. And the only difference with this is we also cut this down to 3x6 instead of 7x7, so we made the frogs a little smaller. And Chris will go ahead and start doing test jumps. Alright, there you go. Alright, so we measure the frog by the tip of the nose, just like before. So as you can see, this one landed at around 5.8.
Alright, so this is our new data sheet. Just like before, the white spaces are where they didn't land in the specifications, and as you can obviously tell, they're way less than before. And if you look closely though, you'll notice that the white spaces, they're all over 6 inches. Now what that means is none of our frogs landed below 2 inches. If they did land outside the specifications, they went over instead of under. So that was just something cool to note. And then if you look over to the right, our CPK is now 0.43. Now, this was kind of bittersweet because although our main goal was to improve our CPK, we didn't improve by the margin that we wanted. So one reason for this is our baseline frogs could have been too high when we jumped them, so that could have decreased our margin of improvement, and that's what we think led to our, I guess, lower CPK than we thought. And this is our new data sheet. As you can see, they're way better with staying the specifications. Before they were kind of all over the place. And this is our new statistics, so our sigma hat, ZU, ZL, and then our CPK, once again, 0.43. And that's it for me. Now I'm going to throw it back over to Harry.
All right, thank you, Chris. And so, again, as we were talking about how we improve through manpower and method and material, we still had to show show the employees on the instructions on how to operate these frogs. Even though you have the instructions on how to make them, we wanted to create these instructions, that way the operators know how to test jump them, and that way you can get a better improved data. Again, so step by step, first you want to take your index finger, place it on the back of the frog between where the numbers and the initials were located, and then you want to press down until the spring is loaded, have the nose of the frog slightly elevated, and then slowly release your finger back until it's no longer touching the frog, and then the frog should spring up into the air and land as properly. And so again, as Holly mentioned about the yield of the first set of frogs, we had about an average of 47% of usable frogs. This on averaging by those test jumps that we did. If we were to create more and more frogs, again, that's what we were looking at with the original baseline frogs. However, the yield definitely improved. As going back to that chart, now we have about 91% of usable frogs. This means that basically on the financial side of it, if we were to create 1 million frogs as your company wanted us to do, this is what it would look like. We would be paying $1 million originally in the cost, but with that $1 million, we would only get 470,000 usable frogs out of the million. That means the rest of those 530,000 would have to be scrapped. Now that's a lot of waste in materials, and that's a lot of cost that's going to go into your company. However, now that we're paying, again, $1 million in cost, this time with higher material costs, yes, but because it did take down our labor cost of time, it will lower the labor cost for the employees. So your company will still end up paying $1 million to make 1 million frogs on improved material. But with that, with the $1 million now, you can use up to 910,000 frogs this time. Right, on the new frogs, you'll be able to use 910,000 frogs as opposed to only 470,000. So again, the benefits do outweigh the cost. You're going to have increase in sales and revenue with this higher quality product. And with the higher quality product, you're definitely going to have a higher customer satisfaction rate. Customers would, when they're more satisfied, they would definitely recommend your product to others, thus gaining a more extensive revenue. And when the customers are happy, you obviously retain them. So they'll come back more to buy more of your products. Once those frogs that they originally purchased stops jumping, they want to come back to you guys again and buy it again. And so you'll definitely have a repeated revenue. Because it took less time to make the frog and cutting down the production by 43%, this definitely saves the customers in time on making it. It saves us time of making it as well. And so again, that's really what we're looking for, is improving that quality and lowering our cost. The yield again would improve by 43%, meaning that again, going back to those numbers, you're going to have 43% more of usable frogs to sell to the customers. And so that's our presentation, and thank you for your time. Ribbon.